guys, welcome back and thanks for checking in. This next math video lesson can be found in your textbook on page 241 if you're following along. It is lesson 5-4 and the title of the lesson is Solving Inequalities. So your learning target today would be that you will learn how to solve inequalities, which kind of is like a lot like solving equations. So we've spent weeks and weeks and weeks working with solving equations, right? The one-steppers and the two-steppers and sometimes the five-steppers. And so all of that learning about solving equations has really been building up, and it's going to come in very handy because today you're going to be solving inequalities, and the process is the same. It's all about the variable, trying to get that grumpy variable to be alone. So I put up here on the screen, under the word inequalities, I put the inequality symbols. So we have the greater than symbol, greater than or equal to. We also have the less than symbol, and less than or equal to. So today, as we're looking at these inequalities, they're going to look a lot like the equations that we've been working with, except instead of an equal sign, you're going to see an inequality sign. Okay, other than that, the process is pretty much the same. So you can see that I've typed on here, and hopefully you're writing down in your notes, that solving inequalities is the same as solving equations. The process is the same. And we always are going to be doing the opposite of whatever's happening in the problem. And whatever we do to the left side of the inequality, we have to do to the right side. And let's not forget one last time, the whole purpose of solving an equation or solving an inequality is to get that grumpy, antisocial variable alone. He does not want any numbers on his side of the equation or on his side of the inequality. He really wants to be alone. So that's always your job, is to get those numbers away from the variable. When we talk about doing the opposite, we mean that adding and subtracting are opposite functions, right? They're going to sort of cancel each other out. And multiplying and dividing are also opposite functions, and they cancel each other out. Now, because solving inequalities is kind of a big idea overall, I decided to break that into two separate lessons. So today, we're really just going to be adding and subtracting to solve inequalities. And then the next video lesson that you watch, that will introduce the idea of multiplying and dividing to solve inequalities. And there's a little bit of a catch with the multiplying and dividing piece of it. It definitely gets a little harder. So we're going to start off nice and easy today with just the adding and subtracting problems. So this is really day one of a 2-day lesson. Let's take a look at some quick examples. And I don't think that this lesson's going to take very long. I think you'll be pleased at how short this video is. Here we go. It says, solve each inequality. Even though there's not an equal sign in any of these problems, we're going to treat them the exact same way that we would treat them if they were plain old equations that had equal signs. So I'm looking at the first one here on the left, and it says x plus 5 is greater than 12. I'm ultimately looking for the values of x that will work in this inequality. What numbers for x, if I add 5, will always be greater than 12? Okay, well, x is the variable, he's grumpy, and he wants to be alone. Who's bugging him? Plus 5. What's the opposite of add 5? You should know, subtract 5 on both sides. Right? There's that cancel out. There's my x. There's my greater than symbol. You know what? Freeze frame. I cannot tell you how many times I have students, as we're really starting to work with these inequalities, how many times students forget that they're working with an inequality and they stick an equal sign there. And you cannot put an equal sign because this is not an equation, right? So be very mindful, be very careful that you're using the right symbol. So that's the greater than symbol. And you have to solve 12 minus 5. 12 minus 5 is 7. And we look at our variable x. He's alone and he's happy. And that's your final answer. Look. Yay, good job. X has to be greater than 7. What does that mean? It means any number that you can think of, as long as it's greater than 7, will work. Pick a number. I'm going to pick 10. 10 is greater than 7, right? Let's check it. If I just pick a number out of thin air that's greater than 7, and I'm going to say 10, and I go back up here and I plug that 10 in, and 10 plus 5 is 15, and is 15 greater than 12? Yes, it is. I could pick another number that's greater than 7. I could pick 8. I could pick 100. And as long as the number is greater than 7, and I substitute it in that inequality, my answer will always be greater than 12. It works mathematically. So oddly enough, x does not just have one correct answer. X has an endless number of correct answers. As long as the number is greater than 7, the number will work for x. Okay, let's check out the next one over here on the right. It says, y plus 10 is less than 3. I look at y, he's grumpy, he doesn't like that plus 10 on his side of the inequality, so we do the opposite of adding 10 and we subtract 10. Minus 10, minus 10, I like the line, I like the canceling. I've got y, I've got less than, and 3 minus 10, don't you dare tell me 7. It is negative 7. So the answer for y is y can be any number as long as it is less than negative 7. Examples would be negative 8, negative 10, negative 100. As long as it's less than negative 7, it's good to go. And again, you could substitute any of those numbers back into the original expression, and you would see that the answer would be less than 3. So process-wise, it's just like working with equations. 2 more. Let's look at the one in the bottom left-hand corner. X plus 7 greater than or equal to 10. Okay, I'm looking at x. He's grumpy. He doesn't want the plus 7. We do the opposite. We subtract 7 on both sides. Divide those 7s. X is not equal to, it's greater than or equal to, and 10 minus 7 is 3. Any value for x will work as long as it is greater than 3 or even equal to 3. Okay? Last one over here on the bottom right corner. The inequality says 3 is greater than g plus 7. I look at g. He's my variable. He's grumpy. He does not want that plus 7, so we subtract 7 there. We subtract 7 here. Cancel out our 7s. I know I've got G. I know I've got the greater than symbol there. And 3 minus 7 is negative 4. So again, if you can imagine, G can be any number at all, as long as negative 4 is greater than G. Negative 4 has to be greater than G. Or if you were to read it in reverse, you'd have to flip everything over. G would have to be less than negative 4. Right? If you want to change what side the variable's on, then you're going to have to change which way the sign is pointing. So any number less than negative 4 will work. Negative 10 would work. Negative 1,000 would work. Mathematically, again I say, for like the 8 gajillionth time, we solve these the exact same way that we solve equations. We just have to be very careful with our signs so that we aren't including equal signs. We have to make sure we're using our inequality symbols. This is the assignment we'll be doing during class. Notice it asks you to show your steps or show your work. And it also gives you a heads up that you will have a few decimal or fraction answers. So no worries there if you get some crazy wackadoo answers. It doesn't mean you're necessarily wrong. It just means some of our answers are not going to be nice whole numbers, all right? So thank you for watching, and I'll see you in class.